Am I audible to all? Hello? Am I audible to all?
Yes, sir.
Okay, so we shall wait for 1 and 2 minutes to join others. After that, we will start our class. We will just wait for the other participant to join. Okay, we'd like to start our class. I'm sharing my screen with you. Is my screen is visible to all?
Yes, sir.
Okay. So we shall start our next part of the previous day. We are starting the planarity of a graph. Now today we are going to learn how to investigate of a planarity of a graph. So that is investigation for planarity. There are some steps. So step one. Step one. If G has a several component, if G is a graph, has a several components, consider only one component. Consider only one component at a time. Now we are going for step two. If any component or G itself is separable, it would have separable several blocks. Consider only one block at a time. This is the step number two. Now we are going for the step three. Remove all self loops. Remove all self loops from G. Since addition since addition or deletion of self loop does not affect planarity of G. Now we are going for the step 4. Step 4 is here. Keep only one edge. Keep only one edge between any two vertices. Between any two vertices by removing all parallel edges between them. Since this does not affect planarity of G. Does not affect planarity of G. Now step 5. If G has two edges, having exactly one vertex in common, and if this vertex is of degree 2, then elimination of such vertex from G does not affect the planarity of G. So remove all such vertices from G. And lastly, step 6. Repeat the above step so long we can. So long we can. So these are the steps to find the planarity of a graph. First is step 1. If G has a several component, consider only one component at a time. If G is a given graph which has the several component, then we should make first one component. Now, if any component or G itself is separable, it would have the several blocks. Consider only one block at a time, right? If it is the face graph, then we are all the face are called the another block. So we are taking block to block. So at a time we are taking the only one block to consider this. Now remove all self loop from G, since addition or deletion of the self loop does not affect the planarity of the graph. If for the given graph G there are self loop is given, then we can remove the self loop. Because of that, if we remove or add the self loop, then it does not affect into the planarity of the G. Keep only one edge between any two vertices by removing all parallel edges between them. Because of that, if there are so many parallel edges, then it is not required to take all the parallel edges. Only one edge we have to take. So we have to remove all other parallel edges. Because of that, removal of parallel edges, it does not affect the planarity of G. So we have to remove the self loop. We have to remove the parallel edges also. Because of that, addition and deletion of the self loop or parallel edges does not affect the planarity of G. Step number 5, if G has two edges having exactly one vertex in common. G has two edges having exactly one vertex in common, and if this vertex is of the degree 2, the vertex is degree 2, then elimination of such vertex from G does not affect the planarity of G. So remove all such kind of the vertex from G. Is it understood? If G has the two edges having exactly one vertex in common, if we take that, this is the common vertex, one edge, second edge, right? G has the two edges having exactly one vertex in common, and if this vertex is of degree 2, that means this and if this vertex is of degree 2, then this vertex having the degree 2, then we can remove this vertex from G. Now repeat all those things as long as possible. Is it clear? How to investigate the planarity of a graph? Hello? Am I audible to all?
Yes, sir.
Is it understood?
Yes, sir.
So we are taking one example to find the planarity, including this thing, right? So we are going for the next slide to take an example. Just wait for 1 second. So we are taking an example. Find whether the graph is planar. The graph is given, G such that this is the given graph. Now we have to check whether the given graph is planar or not. So this graph having the number of the vertices 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vertices. So V equal to V1 dot dot V10. and age is equal to 1, 2, 3, 4, 5, 6. Then it is 7, 8, 9, 10, 11, 12, 13, 14, 15. So it is E1 to dot E15. There are 15 edges and 10 vertices of the given graph. Now we have to show that whether the given graph is planar or not. So we shall check it. If it is the vertex 10, if we give the name of the vertex, that is the V1, this is the V2, V3, this one is the V4, this one is the V5, this one is the V6, and then it is the V7, is the V8, it is V9, and this one is the V10, right? We see here the vertex V10 in G is a cut vertex. So G is separable. Cut vertex means from which vertex we can make some blocks, right? So for this vertex we can make some block. So from V10 we can make some block of this. So it is separable. Two blocks of G are given below. नीचे हम लोग लिखेंगे. This is one block, that is V1, V2, V3, V4, V5, V6, and it is the V10. This is one block. This is, we can write down, that is G1, and another block would be this one is V9, this one is V7, V8, and this is the V10. So there are two blocks. This part means this small part, and from here to here, this is the main part. This is the there. So the graph G is separable as the V10 is the cut vertex. So it can be made into the two blocks. One block is this and second block is this. So G can be made into the two blocks. Is it clear?
Yes, sir.
Now in G1, the vertices V1, V3, and V5 has degree 2 each. Degree 2 each. These are also common vertex to the edge. These are also common vertex to the edges V1, V2, V1, V6. V1, V2, and V1, V6. Etc. So in G1, we remove the vertex. We remove the vertex. Actually, vertices V1, V3, V5, and G1 is converted to so we are removing V1, V3, and V5, right? These all vertices have the common vertex V1, V2, V1, V6, as well as for V3 it is V3, V2, V3, V4. For V5 it is V5, V6, V5, V4. So here this vertex is common to the both edges, but degree of this vertex V1, V3, and V5 are 2, right? So we can remove this V1, V3, V5 from here. Then we are going for the next part. So then the graph G1 is coming into the part of this is the V2, this one is V4, this one is V6, and this one is V10. So G1 remove into this. Now this graph is planar. Since every edges, edge of this subgraph is drawn without having any crossover, Similarly, other block G2 is also planar. So here the graph block G1 is planar. Because of that, this graph is planar since every edges of this subgraph is drawn without having any crossover. Look at here, any edge is not cutting each other here. So this subgraph G1 is planar, as well as in the previously G2. G2 was this one. Here also you can say the same thing for the G2 also. Sorry. Actually, G2 was this one. So now the remove of G1 and G2, it was the G2. G1 and G2, actually G2 having it was the V7, it was the V8, it was V10, and it is V9. It was the G2. It is similar to this G1. So it is also, this one is also a planar graph. So for the given graph, for the given graph G, the two blocks G1 and G2 both are planar, which leads to the condition, to the conclusion that the given graph G is planar. Is the answer? Is it clear?
सर
हाँ बोलो.
सर ग्राफ G1 में V1 V3 V5 वर्टिसेस को हटाने के बाद यहाँ पे एज क्रिएट किया गया है.
कहाँ पे?
V2 पहले से सर V2 और V6 के बीच और V2 V4 के बीच और V4 V6 के बीच एजेस नहीं थे ना?
नहीं थे, लिखते. ये V2 V4, V2 V6 and V6 V4 ना, ये एज के बारे में बोल रहे हैं ना तुम?
Yes sir.
It was not in the previous. Here, that's why we are saying that we see that the vertex V10G is a cut vertex. Cut vertex means from this cut vertex we can make sure that there are two blocks will be coming. Blocks mean a complete, actually a closed graph. If we take that V10 is the cut vertex, then with respect to this V10, there will be two graphs. Number one graph is coming that this V1, V2 to this one, and another block, this will be added. This is the, these are added. So this is one block and another block is this. Clear? When we removing the edges, V1, V3 and we are just from इसको remove किए, और इसको ना, isn't it?
Yes sir.
Look at here. For this graph, how many edges of there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Na? 9 edges was there. Isn't it?
Yes
So
sir.
if we cut one vertex, this is called the cut vertex. So from here, this V1, V3 and V5, they are cutting there and we are making the block. So we are taking this one, this and this. Then it is coming like that. Then after cutting this V1, V3, V5, this G2 and G1 will be the same, na? G1 and G2 will be the
समझ
same.
आ गया. बस वहां से वर्टेक्स को हटा दिए हैं तो खुद एक एज बन गया.
Edge.
Yes
For
sir.
the two edges, instead of two edges, we are putting one edge. Right? Then this modified G1, this G1 will be coming that this part. If we say that this is the G1 dash, this changes into G1 dash. Now G1 dash and G2 both are equal. Now we are proved that G1 dash is the planar graph. So as well as G2 also planar. Look at the next part. Here from G1 dash and G2 both are equal. Here this graph is a planar since every edges of this subgraph is drawn without crossing over, having any crossover of the edges. Similarly, the block G2 also planar, because of that both are the same right now. So this is also the planar graph. So both of the planar graph. So both of the blocks are the planar. That means the given original graph also planar. Is it clear?
Yes sir, clear.
Now we are going for the dual of a graph. Dual of a graph. Dual means actually inverse. Now there are definition. Let G be a graph. Let G be a graph having n number of region, having n numbers of regions. Regions means actually face. F1, F2 dot dot Fn. We place a number of points, V1, V2, Vn, V1, V2 dot dot Vn, 1 in each of the region respectively. These points are joined by line segment accordingly to the following procedure. What is the procedure? Procedure is if two region F1 and F2, Fi and Fj, Fi and Fj are joined by a line, segment intersecting the common edges between Fi and Fj exactly 1 and Fj exactly once. If there is more than one, edge common between Fi and Fj, we draw one segment between Vi and Vj for each of the common edges. Number 2, if an edge E if an edge E of G lies entirely in one region, if K, draw a loop at VK, intersecting the edge E, exactly once. Thus we get a new graph G star, whose vertices V1, V2, Vn, and the line segments joining these are edges, are edges. This graph G star, is called dual. It is also called or geometric dual of G. So how to make the dual graph? Look at here. Let G be a graph having n number of region, that is n number of the faces. Already we know that what is the face graph, n number of the faces. We places a number of the points v1, v2, n, vn, one in each of the region respectively. In each and every region, we are putting one vertex. These points are joined by line segment according to the following procedure. What is the following procedure? If two regions, Fi and Fj, are joined by a line segment intersecting the common edges between Fi and Fj, there are two regions, Fi and Fj exactly once. If there is more than one edges common between Fi and Fj, we draw one segment between Vi and Vj for each of the common edges. Now, if an edge E of G lies entirely in any region, one region Fk, then draw a loop at Vk, intersecting the edge E exactly once. So this is the procedure of drawing of a dual graph. At first, we have to put all those for the face. There are n faces F1, F2, Fn, and there are n vertices V1, V2, Vn. Then first we have to put in every faces or region one